everyone, today we are going to be repairing an organ that I previously featured on another video. Of course, with the 7-year-old pieces of equipment, there's always going to be an endless amount of tinkering involved, especially with the ones that are newly acquired. And unfortunately, that's just kind of what you get when you're working with vintage equipment. It's kind of like gold in an old car. There's always some maintenance that will need to be done eventually, even if you have something that is working correctly at the moment. So onto this particular piece of equipment, I'm having two issues, one major and one minor. The minor issue consists of us doing a basic recap job, which involves replacing all of the electrolytic capacitors inside. This is standard maintenance on an old piece of gear, which is why I'm considering this a minor issue. The major problem, however, is involved with the lower deck keys, and these keys are starting to break one by one. And after the second straight key breaking in a matter of hours, I knew we were going to have some serious problems moving forward. And the problem that I'm having lies within the key's action mechanism, which consists of two very thin wires being pushed together by the physical bending of said wires in order to make electrical contact. And when that electrical contact is made, that's when the tone of the key is played. In order to better explain what's going on with these keys, I drew out a diagram, and I hope that this will make it easier for you guys to understand of what I'm dealing with here. If you look all the way to the left of the diagram, I have pointed out a few key items, and you will see the wire being pointed out, which is the blue line going all the way down. There is the grommet, and this is the metal piece that holds the wire, and grommet is definitely not the correct word, which is why I have that in parentheses. I don't know what to call this piece, but for today we're just going to call it the grommet because that's the best identifier that I could think of. And that wire is held in place in that grommet with solder. And after repeatedly getting bent by the key's action mechanism, and the wire keeps breaking at that weak point that I have drawn out in a little red dot. And if you look at the next wire over in this diagram, you could see how that wire is breaking off. And when the first key broke, I didn't get nervous until I tried to fix the issue and I was running into a lot of problems. The first thing I tried to do was to just resolder the broken wire back into place and try to push it a little farther down in the grommet so it would be bending at a new weak point. And I found out pretty quickly that this was not going to be possible. It became very difficult to take out the piece that was broken inside the grommet, and even when I could successfully resolder the pre-existing wire back into place, it was not a long-lasting solution. This is the point I realized that I was going to have to do some preventive maintenance on all of these keys because I did not want to have to retroactively fix all these broken keys in this manner because it was taking me matters just to get something that kind of worked. So my initial plan was to get a substitute wire and replace all of the existing wires. And of course, my life had to be difficult, and I could not find a suitable replacement wire. The wire used originally appears to be brass, which I don't think is a necessity. I'm certain any metal will work. The things that are a necessity, though, is that I need a very small diameter wire, about 0.015 inches as measured by my calipers. And this wire, although it is very thin, it has to be stiff and flexible, some sort of spring steel and not a carbon steel type of metal. And I couldn't find any suitable replacements at the hardware store. I tried several options, and I found some material online that I could have ordered, and it could have took maybe a week or two to get to my house, but I was incredibly impatient and wanted to find a quick solution. I had basically given up at this point. I was so frustrated. It was past midnight, and I had to go to bed. I had to wake up early in the morning for work. I laid down in bed, and the solution to my problem finally hit me as soon as I laid down in bed. Guitar strings. Guitar strings are the perfect material for what I was looking for. I could open up a standard 6 set of strings and find the correct diameter that would work best for the application, and the wire itself is stiff and flexible, and it wound up being the perfect type of temperament that would work for this application. And And at this point, I was super excited that I figured out a possible solution, and instead of going to bed to get a good night of sleep for work tomorrow, I figured I might as well start filming and replacing the strings, or wires rather. And I started replacing the first key's wire all the way to the left of the lower deck, and it wound up being a little more difficult than I was expecting. And instead of replacing every single key in this method, I thought of a different solution instead. By simply heating up the grommet and allowing the solder to melt, I could then push down the existing wire further down into the grommet. And by doing this, I am putting the weak point that is being stressed for the past 70 years on this organ, and it's pushing it down farther into the grommet where it is going to solidify inside solder. And then when I keep using the key moving forward, a new weak point is going to be flexed. And I am hoping, at least the plan is, that this flexing is not going to break these existing wires until 70 more years. I might be wrong, and I might need to replace all of these keys in the near future again, but a side product of me trying this new method of just simply moving the existing wires downwards allows me the ability to easily pull out the wire if it gets broken inside the grommet later, because now if you look, a piece of the existing wire will now be sticking out of the grommet on the bottom. And I'm just going to keep a spare piece of guitar string inside this unit in case in the future I need to do this repair, as I just said, and the material will be ready for me to make the change. And once I get done moving all of these existing wires down into their grommet a little more, I'm then going to do a complete cap job on this organ's electronics. And for the uninformed, a cap job is when you replace all the electrolytic capacitors inside a unit, and this is standard maintenance on an older piece of gear. Electrolytic capacitors lose their capacitance due to age and need to be replaced. I am hoping that once I do this cap job, that is going to clean up a few things with the sound of this unit. There's a lot of distortion when you play these keys, and I don't know if that is a product of needing a cap job or if that is a product of the electrical contact mechanism on this organ. And, you know, as I mentioned before, this is a cheap, low-end organ, and I have a feeling that distortion sound is just a product of the lower endness of this unit, and I don't think a cap job is going to fix it, so we'll see how that goes. And I'm also having light background noise and hissing problems and popping noises every now and then, and once again I'm hoping the cap job alleviates this issue and it's not something deeper. And cap jobs are traditionally pretty easy to do. The hardest part in this case is just going to be removing the electronic circuit board from the organ chassis. Once I get these circuit boards out and onto my work table, it is going to be a breeze replacing these capacitors. I bought the replacement capacitors at Antique Electronic Supply. I recommend this company if you're doing projects like this every now and then and you're not someone who is often making electronic products and needs a large quantity of capacitors, because this company allows you to get smaller quantities for a cheap price, whereas a lot of companies have a minimum amount you need to buy for capacitors, and that can quickly make your simple repair project really expensive, where I think I only spent $10 total for the electrolytic capacitors for this project, and you know, I bought double of everything just in case I needed extras and I could use them in the future. So, you know, realistically I could have did a cap job on this organ for about $5, and once again I can't recommend this company enough because I've had a really good experience with them and really good prices. And long story short, let's just kind of skip ahead throughout this whole process while I'm doing the cap job, and we'll go on from there. Alright, so I got all the electrolytic capacitors replaced. I have to put everything back inside the organ chassis, do everything in reverse, and it's always really helpful to take pictures initially before you take everything apart. This way, when it's time to put everything back together, you know exactly where the wires have to go, and you don't accidentally cross anything or do anything wrong and potentially screw something up. I also took this time to clean up a lot of the insides of this organ and get all the dust that's been accumulating over the 70 years of this sitting out. And I finally get everything back together, and it's time to test my work to see if I'm getting a sound. And thankfully we have sound. Although the sonic quality of the sound is exactly the same as it was before the cap job, the only difference is now the actuator lever on the lever controls works, so that is exciting. And other than that, I'm still having slight hissing and popping in the background through my amp, and I think that just might be a product of the transistors in the circuitry maybe needing to be replaced. And honestly, I don't care enough to go through the extreme effort of replacing everything on this organ. This organ is pretty lower end, and it's probably not worth the effort of pulling my hair out. The key action mechanism alone is enough to make me not like this organ. I'm constantly dealing with issues, and if you don't hit the notes hard enough, they don't produce a clean tone. If you hit them too hard, you get bouncing on the electrical contacts, and it's just, I can easily see why Estey didn't make a lot of electronic organs, because if this is any indication of their design work, it's not going to do in a professional setting, unfortunately. And although I really would love to save up for a nice Rhodes electronic piano, something like this is going to do for now, and it certainly fits my garage aesthetic. And it's not that I totally hate this organ. I do love it. It's got its own little character and everything. It's just, it's a little frustrating at points, and hopefully this is the last video I have of repairing this thing, and I hope that going further, it's nice and smooth sailing. So we'll see. Hopefully we don't need to update this series. And that's it for today. Thank you guys for watching. I'm going to close out this video with an excerpt of a song that I recorded featuring this organ. Thank you.